Okay, concurrent viewers, for some, hi, Devin, I don't know why I don't know, if I might be having trouble with my internet, but for some reason the last video just stopped viewing. It might be because I tried to play that YouTube video. Let me pull the slides back up, and I'm going to pull the video back up, in a different window.
Good grammar and spelling are important, but if you want to write essays that inspire, messages that forge bright...
In this video, we're going to talk about how to use the resistor color code in order to determine the value of a resistor. So the first color, reading it from left to right, is for the first digit. So the first color is red. Well, let's actually use the color red. The second color is yellow. The third color, let's just say it's orange. The last color is for the tolerance. It's usually either gold, silver, or no color. So let's say this is gold. I'm going to put a G for gold. So what you need to do is, when you have the first color, which is red, look for the number in a table. So red corresponds to 2. That's the first digit. The second color, yellow, correlates to the second digit. And based on the table, yellow is associated with 4. So you can have 24 or 24. O, or orange, is 3. But the third number is the multiplier. The first 2 letters corresponds to the first 2 digits. The third letter corresponds to the multiplier, which is 10 to the third. So this is 24 times 10 to the third. And the last color is the tolerance, which is usually gold, silver, or no color. So since we have gold, the tolerance is 5%. So it's going to be plus or minus 5%. Now, what is 10 to the third? 10 to the third is basically 10 times 10 times 10, 3 times, or just 1,000. So 24 times 1,000 is 24,000. So that's the value of the resistance. It's 24,000 ohms. Now, because this number is so large, let's convert it to kilo ohms. To convert it to kilo ohms, just divide by 1,000. 1 kilo ohm is equal to 1,000 ohms. So therefore, this is about 24 kilo ohms, plus or minus 5%. Now let's go ahead and calculate the range. So what we want to do is find out what 5% of the resistance is equal to. So right now we have 24 kilo ohms, plus or minus 5%. So let's multiply 24K by 0.05, which is going to be 5% of it. And that's about 1.2 kilo ohms. So the actual resistance can vary between 1.2 kilo ohms from 24 kilo ohms. So it could be 24 minus 1.2. So it can be 22.8 kilo ohms on the low side, or it can be 24 plus 1.2, which will be 25.2 kilo ohms. So based on this information, the resistance is about 24 kilo ohms, but the actual value can be anywhere between 22.8 and 25.2. And so you should always check the tolerance level to see where the true resistance may lie. Now it's your turn. Go ahead and calculate the value of this resistor, determine the tolerance level, and also the range in which the true resistance may lie. So the first color is green, the second is blue, the third is red, and the fourth, which is the tolerance, is silver. So the first color is associated with the first digit. Green has a number of 5. So the first digit is 5. Next we have blue, which is associated with 6. The second color is for the second digit. And then we're going to multiply. Now, the third color is for the multiplier. And since we have red, the multiplier for red is 10 squared. So we're going to multiply by 10 to the second power. And then the last color is associated with the tolerance. For silver, the tolerance is 10%. So it's going to be plus or minus 10%. 10 squared, or 10 times 10, is 100. So 56 times 100 is 5600. So that's the resistance. It's 5600 ohms. Plus or minus 10%. Now let's calculate 10% of 5600. So 5600 times 10%, which is 0.10. To convert a percentage to a decimal, you can divide by 100 or move the decimal point 2 units to the left. 5600 times 0.10 is 560. So basically, we need to add or subtract by 560. 5600 plus 560 is 6160, and 5600 minus 560, that's 5040. So the actual resistance could be anywhere between 5040 ohms and 6160 ohms, with the average value being around 5600. So this is the resistance, and this is the range in which the actual resistance can be. Here's another one you could try. Go ahead and calculate the resistance using the resistor color code and determine the tolerance and also the range in which the true resistance can lie. So feel free to pause the video and see what the solution is going to be. Unpause it whenever you're ready. So the first color is yellow, the second one is purple or violet, the third one is green, and the last one has no color. So the first color is associated with the first digit. So yellow corresponds to 4. The second color is for the second digit. Violet corresponds to 7. The third color is for the multiplier. Green has a multiplier of 10 to the 5th. And the last one is for the tolerance level. For no color, the tolerance is very high. It's 20%. That is plus or minus 20%. But let's deal with the percentage later. What's 47 times 10 to the 5? 10 to the 5 is basically 100,000. It's a 1 with 5 zeros. And if you multiply 47 by 100,000, that's going to be 4.7 million. Or 4,700,000. So that is the resistance level in ohms, which if you put it back in scientific notation, by moving the decimal 6 units to the left, this is equivalent to 4.7 times 10 to the 6 ohms. Now, 10 to the 6 is basically a million, which represents mega. Mega is equal to 10 to the 6. So this, you can write it as 4.7 mega ohms. Anytime you have a value above 1,000, it's common to write it in terms of kilo ohms. If it's above a million, you want to use mega ohms. So now, what is 20% of 4.7? So if we multiply 4.7 by 0.20, don't forget to divide 20 by 100. This is going to give us 0.94. So the resistance could be anywhere between 4.7 mega ohms plus or minus 0.94 mega ohms. The unit has to be the same. So the lowest value is going to be 4.7 minus 0.94, which is 3.76 mega ohms. And the highest value is 4.7 plus 0.94, 5.64 mega ohms. So the average resistance for this particular resistor is about 4.7 mega ohms. The tolerance level is 20%, and the range is between 3.76 and 5.64. So this resistor can have any value in this range, but most likely it's going to be around 4.7 mega ohms.
Okay, could everybody see that video? Just want to make sure we're back on track here because I had changed the video because it froze on me. It kicked me off. It looked, for some of you it cut to a new video, and for some of you you had to log into the second video. So just so this is a different color code table from what was in that previous video I showed you. But anytime you guys are calculating resistance for resistors, you will be using whatever table is either attached to your project or attached to your test, or like the table will be given to you. So in this example, I have a resistor and I have a cool little picture down here of a resistor, and this resistor actually has more than 4 bands. It has 5. So which you're going to see. You're going to see different numbers of bands. So when you do see that, what you want to do is you want to kind of work backwards, forwards. Rodney Lima, yeah, I see on my video it's buffering a lot too. I think it is mine. Yeah, OBS is like this new thing for me. This is how I can share the slides with you guys. I'm not really sure how to fix that. So we're just gonna have to deal with the buffering until I can look into it. So this picture down here has some examples of your bands. So with this one, with 5 bands, your last band is always going to be your tolerance band. Your second to last band will always be your multiplier, okay? And then any bands in front of that are going to be your whole number digits. Okay, so this example has has 5 color bands on this resistor. So we're going to take the first, second, and third color bands, and we're going to take the whole number digits. So according to our chart, which I know it's really small here, but you guys have the same chart on a different slide. So according to our chart, we have a brown, in our picture, we have a brown band and 2 black bands, is what I'm calling it. Okay, so that's going to give us the whole numbers 1 and 2 zeros. So basically 100. Our color band is brown. If we go to our chart, the color brown as a multiplier is going to be 10 to the first power. Okay, so just 10, which means we're going to take our 3 whole numbers in front of that, 100, and multiply it by 10 to the first power. So we're just multiplying 100 by 10. Yeah, my OBS, I don't even really know what OBS means. I just know I can share the slides with you guys when I use it. For some reason today it's buffering a lot, so I'll have to look into that. It hasn't been doing that to me recently until today's lecture. So I apologize for any inconvenience that causes. You're just going to have to bear with it. So moving on in the formula, the next step would be, so we have our 100 here, we're going to multiply it by 10, that gives us 1,000 ohms, okay? Now, with 1,000 ohms, we want to find our range. If you don't know how to multiply by a percentage, you can go back and watch that video, it explains it more. Okay, so here I multiplied our 1,000 ohms by our percentage, and that gives us 20. Okay, so we want to subtract and add that to the minimum and maximum values for our range. So in this example, our range would be 1,020 ohms to 980 ohms. That's the range of this specific resistor. But we can take that even further and make that into 1.02 kiloohms. Sorry, my dog is whining at the door now. Okay, so anything over 1,000 ohms, we always want to see if we can convert that. You know, if we had it in 1,000,000 ohms, we would convert it to milliohms. Okay, so we want to convert that to 1.02 kiloohms to 980 ohms. That's the range of our capacitor, of our resistor. The nominal range is 1,000 ohms, but it can be in limits anywhere from 1.02 kiloohms to 980 ohms.